All right, so we're all back in the main room now, and each group's been assigned a different question or a different part of a question. So we're just going to work through the groups and have you explain the part that you were given. Let's see. So group 4, you guys are starting us off with the beginning of question 1, right? So Gavin, Jackson, and Roy, if you guys can, okay, that's fine, Atticus. If you guys can go ahead and get us off to a good start here, we'll look forward to hearing from you.
All right, so the first question A asked for like describing the motion on the motion map and so the 4 things that you need is time, distance, the rate, and like the direction it goes in. So you have like 5 seconds for the motion map. You have 10, you go away from the origin, or you go away from 0 meters, like you go 10 meters in that time. And like it goes away from the origin and it goes at a rate of 2 meters per second. So that's like everything that you would need for A. So yeah.
Can I share my screen for B?
Yeah, go for it.
Okay, so for B, I drew a graph here. So like position would be 1 meter here, 2, 3, 4, 5, and 6. And then so for this is 1 second here, and then this is 2 seconds here, and then 3, 4, 5, and 6. So it goes 2 meters per second. So it's like every 2 meters, or every 1 second it increases by 2 meters. So it goes like this. Yeah.
So Roy, so your scale on position is also 1 meter per line?
Yeah.
Okay, so you just showed on the graph the first 5 meters, right?
Yeah.
Basically,
right.
5 or 6,
Right.
yeah. Okay,
Yeah.
all right.
All right, so then for part C, basically, so what you're trying to do is you're comparing the velocity over the time, and based on this graph here, so over I believe 1, 2, 3, 4, 5, 6 seconds, it moves 10 meters, or so like, it moves at a rate, the velocity of 2 meters per second. So this is the graph here. It doesn't have units here, but this is like 1 meter per second. This is 2 meters per second. And so this is just a constant line going across, representing 2 meters per second as the constant velocity.
Okay, good. I like, for the first part, for part A, I like the way Jackson reminded us of the 4 things that you need to make sure you include. So position, direction, time frame, and rate. So those 4 things you'll want to make sure you include when you give those descriptions on the test. And then I'm going to show you mine for part B, just so most of the students I've seen so far scaled the y-axis different, and I just want to talk through that briefly in case you also scaled it different. So here is mine for part B and C. And so you can see on my x-axis, it's just 1, 2, 3, 4, 5. But then on the y-axis, it's 2, 4, 6, 8, 10. So I could get the full 10 meters on there, which means when you graph it, it looks like it's a 1-to-1 ratio. So you have to be really careful if you do change the scale, which I think it's fine. If you don't change the scale, then you don't actually see the full 10 meters. But if you do see the scale, it may make you confused on the slope. Because if you just look at the angle, it looks like, oh, that's a slope of 1. But if you don't recognize this y-axis is changing at twice the rate of the x-axis. And then over here, don't worry about this gray box. That's actually for part D. So I was just putting that on there to visualize part D. But I wanted to make sure you could see B in case you scaled yours different. Questions about A, B, or C? All right. Then I think we've got Carson, Frank, and Lily doing D, E, and F, right?
Yeah. Can I share my screen?
Sure.
So for question D, it asks for the mathematical expression. So it said position is going to equal your rate, which is 2 meters per second, times the time. And then if you want to add it, it would be plus 0 meters, and you have to put the meters on if you add the 0. So
Yeah.
checking it out right now. And then for the second question, it asks for the displacement from 1 second to 3 seconds, and displacement is the change in position. So at 1 second, it was at 2 meters, and at 3 seconds, it was at 6 meters. So then that would get you 4 meters, 4 meter change in the positive direction. Yeah.
Yeah, it's
That
6.
was
Yeah.
just it.
Yeah, I accidentally wrote the answer instead of the initial.
It's all good. So I'll just wait.
Yeah, sorry, this is taking longer than I anticipated.
So for question F, we have to look at the graph for C. And when we look at it, it asks for between the time 1 second to 3 seconds, which only 2 seconds really passed. But therefore, you kind of have to use 2 times 2 equals 4, since the velocity is 2.
And also on that one, since you're multiplying 2 meters per second by seconds, the seconds would cancel and just leave you with meters. And that would give you, yeah.
I don't particularly know how to draw that, but that's the velocity graph where you have a line that's constant. And so if you took the area from 2 seconds and 3 seconds, you'd have an area of 4. Attempting to do a visual of it on whiteboard.
Yeah, that's good. Looks good. I'll show mine as well just for comparison, but everything looks good here. And on, I'll just reiterate what was already said. Can you put that back up?
Oh, yeah.
I'll just reiterate what was already said for part D. They've shown here without the plus 0 meters as the y-intercept, which is fine. And that'll be one difference I'll show you on mine, that it does include it. For part E, I think they did it exactly like I did it. I don't think there's any difference there. And then for part F, that's kind of that box that I was showing you on the graph, which is very similar to what she drew here. So really not much different for me to show you mine. But any questions about D, E, or F before I just put mine on the screen? All right, thanks, Lily. So like I said, I'll share mine just for a couple seconds, but there's not really much different. The only thing is, like I said, for D, I've added the 0 meters and I put the whole word position and time. You could use, they used P instead of X for position, that's fine. And they used capital T. I would just, it's okay because you can define the variables with whatever you want. Later, we are going to learn a version of a variable that is a capital T. So I would just, for just knowing what's coming ahead that you don't know yet, I would get in the habit of using a small t for that. But either this way, like more like they did it, or this way with full words with the y-intercept, both of those would be acceptable. Like I said, E was pretty much exactly what they did, and then F was really the same too. But I just had this box to visualize basically like she did as well. So really not much different, almost the same exact thing. All right, moving forward then, unless any other questions on page 1?
For question E, we must put a delta in front of X, right?
I mean, you wouldn't lose points for not having a delta, but it's more precise to have that, yes.
Okay.
Yeah, often you'll see the delta is sort of understood and not always written. So you wouldn't lose points for not having that.
Okay, thank you.
Anything else on page 1? All right, page 2, I believe Haley, Mark, and Ryder are going to show us the graphs and motion map.
I have to rotate this. There we go. So the first one, which is A, you just kind of plot all the points and then just graph it. It's pretty simple because it's given right here. And then for B, you find the velocity for each time and put the velocity down. And these are kind of dotted. These are dotted lines right here. And it was a little messy, so I highlighted where the actual velocity was. And then Ryder, do you want to explain?
Oh yeah, sure.
C?
For C, you're starting at 0 meters, and the very first dot that he has would be the start, and then you would go through and like plot all the seconds, and then for the end there would be 1 dot at the end, and that would be the end of the line.
All right, the only thing I would mention, it looks like on the first graph for A, I think the very end of it, the line kind of goes crooked. It's supposed to hit at 9, I think, on the time. So kind of angles at a funny angle there at the end. Other than that, I think it was just putting the dot in the wrong place for that last dot. I thank you for highlighting those flat bars. That makes it much easier to see. And like Ryder said, putting a dot at the end of the motion map would be important, just to know that there is an end point. We don't really know. You could put an arrow on the end or not, because we don't know for sure if it keeps moving or if it stops. You probably want to put, in fact, you need to put either start or begin or something at the dot where the map does start, so that it's clear. Let me show you mine so I can make sure you understand why that's important. But thank you, group, for that good work. So without trying to show the rest of the work here below. So that, yeah, the graph looks just the same. Mine, I didn't put the dotted vertical lines in like he mentioned, and I have a little box here it's actually answering one of the questions below, just looking at the area again. So you don't need this gray box, and you probably will have the dotted lines or dashed lines connecting them vertically, like Mark mentioned. But I mainly wanted to talk about the motion map. You do need to indicate where it starts, because if you don't have this, we might assume it starts over here, and then it was still for 3 seconds and then moved backwards and then went forward again. So we always want to pick which dot, especially when it's sort of cyclical like this. It's not always perfectly clear where we should start, because it doesn't have to start at 0 meters. If all we have is the motion map, we need that reference point. You don't necessarily have to put end if you have the start marked clearly, but I always recommend that you put the end as well. And then whether you have an arrow on this last dot is either or is fine, with or without, because we don't really know from the graph. The graph stops, but we don't know if the motion actually stopped. So just putting a dot is fine, or putting an arrow on that final dot is also acceptable. So any questions on A, B, or C? Notice the number of dots: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 dots to show 9 seconds, because you always have that 0 and end. So you've got your 9 seconds are the span between the dots. You always have 9 spans between dots and 10 actual dots. All right. If there are no questions, we'll move on to group 1. And it looks like Atticus tried to come back. Oh, no, he's here. Oh, yeah. It just isn't, you're just not listed in that group anymore for some reason.
Oh, yeah.
But you were in group 1, right?
Yeah.
Okay. All right. So we got Atticus, Carter, Jenny, and Jilly. They're going to talk to us about D through G.
I think on D. So the displacement between 3 and 5 seconds would be 6 meters. If you measure the space below, because it's 2 seconds times 3 meters over seconds, so the seconds cancel out and it's just 6 meters.
Okay, I am E. Is it alright if I screen share?
That'd be great.
I think this is it. I'm pretty sure I'm sharing the right thing right now.
Yep.
So for E, determine the displacement from t equals 7.0 seconds to 9.0 seconds using the velocity versus time graph. So at 7 seconds, it's 0, and then from 8 and 9, you're going to be adding -5 plus -5, which gives you a displacement of -10.
Okay, I had F, and then I'll screen share too. And so I just added from 4 to 8 seconds. From 4 seconds, it was 3 meters per second, and then 0 meters per second for 5 and 6. And then through 7 and 8, it was -5 seconds. And so the average velocity was -0.5 meter per second. I don't know why I wrote forward. It was just -0.5 meters per second.
And then I have G. I'll also share my screen. So it's the average speed is like the total distance divided by the change in time. So basically it's just 3 plus 0 plus 0 plus 5 meters over 8 minus 4 seconds. So you get 2 meters per second.
Okay, good. In case any of those shares were too fast or you just want to see it for a little bit longer time, I'll put mine up and just make a couple quick comments. For D and E, for D, that's what this little gray box is for. I was just trying to visualize because the question specifically says using the velocity time graph. The velocity time graph tells you displacement if you know the area under that portion. So from 3 seconds to 5 seconds is this little square. And it's not quite a square, I guess, because it's 3 tall and 2 wide. So 3 times 2 gives us an area of 6. And as I forget who it was that mentioned this one, but they talked about the units being meters per second times second, which gives you meters, which is shown here in the work under part D. And then part E, I didn't draw a box on this one, but it's basically, you know, this wide, 2 wide, all the way down here. So, and I think it was Atticus talked about there's -5 here and -5 here. That's fine. Or you can just think about it as 2 wide and -5 tall, negative because it's going down. And for D and E, the sign is important. So really for D, we probably should, I don't think I can add a sign to that since it's a formula image, but I could say forward to indicate that that's the direction. And then for part E, it's got the negative sign in that image. So you can tell for sure that it's backward in its change in position. Now you can check these from the position time graph, going from 3 to 5. Here's 3 seconds, and here it is at 5. So it's going from position 4 to position 10. So that's a 6 meter difference. It just specifically asked you to use the velocity time graph. So that's why I took an area approach. And you do need to be able to think of both because you may not always be given both. So if you're given the position time graph, you can figure out this 6 meters easy just by looking at the graph. But if you're only given the velocity time graph, you need to remember that it's the area under the line that tells you displacement. Same thing for E, from 7 to 9 seconds. If we just look at 7 here at 10 and 9 down there at 0, it's going backwards 10 meters. So you can get it, since you have both graphs in this example, you could get that answer from either graph and sort of check your work. For part F and G, I saw on Jenny's paper for F, she did it a little bit more like I did, and I think it was Jenny's. I'm forgetting who said which parts now. The way that the letter F was shown on the explanation was different than I approached it. Not wrong, but just different. And so I approached it more as the definition of average velocity is change in position over change in time. And its final position was 5 meters. Its initial position was 7. So that's a -2 meter change in 4 seconds. And so the end result's the same, whichever approach you take. And then for this one, I did it just like it was demonstrated, the different movements in those seconds. It moved 3 meters in 0, then 5. So any questions on page 2? All right. Well, this worksheet is a good review resource as you're preparing for the test. And it is also due tonight by 11:59 p.m. So make sure you get that scanned and uploaded onto Access for today's assignment. We've obviously gone over every question, and you hopefully have been correcting and fixing it if you needed to. So you should have a perfect paper for me to just glance over and give you points for completion. But it will be good, as will the first 3 worksheets, be good resources for you as you're preparing for the test on Thursday. All right, let me tell you a few more things about the test. You may want to follow along on Access. So if you're not logged into Access, I would encourage you, you may want to go ahead and do that. Or you can just follow along visually with me, your choice. So a couple of things. The test Thursday. I've said a few of these before, but in case you missed it or just need to hear it again, 15 questions. It's made to be a 45-minute test, but you will have about 70 minutes, so you shouldn't feel rushed. And mainly I'm doing that because it is on Access and we haven't done that yet. So since it's our first time, I want to make sure you have a good buffer of time. It is all on Access, so no downloading, no printing, just you'll be answering everything in Access. You may not use your notes. You may not use any other resources. So I'll be trusting that you'll be showing academic integrity by keeping all those things put away. The only things you can use are a calculator, which you can use on every question. And then if you would like, you can download this physics equation sheet. There's a link for it right here on the bulletin board page down here under downloads. I can't think of any reason why it would help you for this test, but if you download it, it looks like this, Advanced Placement Physics 1 Equations. There's a lot of good information on here, but none of it is applicable yet. It all starts next unit. So I don't really think there's any reason for you to have this, but you can always use the calculator and you can always use that reference sheet. And those will be the only resources you'll be allowed for this test on Thursday. All right. If you go to assignments, you should see, it's going to show up twice on mine, but you should see test on unit 2. Mine has this unit 2 test with a slightly different title because that actually has the questions in it. So you can see that's why it says 0 of 14. That means I haven't graded any of them yet because we haven't taken it. This one, you should see this one. And if you click on it, you will be able to see in the description some good information here for you, which I'll just breeze through here. There are 8 multiple choice questions and there are 2 points apiece. You cannot get partial credit on the multiple choice though. It's just all right or all wrong. There are 2 points apiece because I want to try to balance the percentage of your score that's based on multiple choice a little bit. Instead of it being 8 points out of 50, I wanted it to be a little more balanced, so it's 16 out of 50. When you take the actual exam in May, the multiple choice is literally 50% of your exam grade. So I don't want it to be so imbalanced that you don't get used to some similarity. The other difference is you would usually have 50 multiple choice and 5 FRQs. And here you can see we've got 8 multiple choice and 7 FRQs. But the free response questions in this case are just portions that I've taken, and I've had to reword them and adjust them a bit so I wasn't using any College Board material. Because I'm not allowed to post College Board material on any sort of online source. So But I try to take questions that are similar to like a part A from a free response, excuse me, or a part B from a free response question, and just kind of rework it so it was more generic and not from College Board. So they're not quite as difficult as what you're going to see as we get further and further into the year. And they're not quite as long as what you're going to see as we get further and further into the year. But that's just kind of where we're at now, where we're only in our second unit. The first FRQ style question is a graph interpretation, and the second one is just like it. In both cases, you're given some graphs, position time, velocity time, that sort of thing, and you're asked to put it in words, to describe in words what the graph is showing. So you'll want to do like, I think it was Jackson mentioned the 4 main things that you want to include: position, time frame, direction, and rate. So make sure you're doing that. The third one is a motion map interpretation. So we just did on this worksheet, number 2, part C, you had to draw a motion map. This is sort of the reverse. It gives you a motion map and you need to put it in words what that motion map is showing. The fourth one is a graph that you need to interpret a mathematical model from. So a little bit like part D on number 1 from this worksheet. Then you also are asked to do a little bit more work with that graph after you've made the model. That's why it's worth 6 points. And then the next one is another graph, and you're going to be interpreting the graph and thinking about the speed and velocity values that you can get from the graph. So there's a couple different parts to that: interpreting it and thinking about speed and velocity. And that is worth 6 points because it's got a couple different parts. The second to the last free response style question is just like 1-sentence answers describing some frame of reference scenarios. So just making sure you understand the idea. You don't have to define frame of reference, but you need to think through some frame of reference examples I give you and explain why the scenario makes sense. And then the last free response question is a graph interpretation where you have to do some ranking. So very much like the last question on worksheet 3 that we did last week, similar to that. And it's worth 8 points because there's multiple parts, multiple steps that you have to answer. All right, so for all of the FRQ questions, you can earn partial credit. And so even if you're not sure how to do the whole question, you should try to do as much as you can. So any questions from you about the format of the test or what to expect?
We can just use Unit 2 review, right, as a practice.
Yeah, I'm going to show you a few things to use for practice here, but any questions about the format of it or what to expect? All right. So to that question then, what should you do to review? Well, I would encourage you to go to topics and go to Unit 2. And in Unit 2, you should have completed worksheets 1, 2, 3, and 4, and I would encourage you to review those. You'll also find a worksheet 5. If there's a PDF form, a document form, and a key. This is not an assignment. It's basically kind of a summary worksheet. It's also a bit of a review. Some years I assign it, some years we just use it for a review. If you open it up, it gives you, like this one gives you a position time graph, and you have to put it in words, make a motion map, and do a velocity time graph for it. The next one gives you velocity time, and then you have to convert it the other way. And so sometimes it gives you the words and you have to convert it. Sometimes it gives you the motion map and you have to convert it. It's basically just a lot of practice doing those different kinds of graphs and motion maps. And the key is right here. So you can check if you're on the right track. There is also a list of Unit 2 vocabulary, so you can make sure you know all the keywords. And then there's a review sheet with an answer key right below it. And that review sheet also has lots of good practice questions for you: interpreting graphs, writing models, determining speeds and velocities. Should be great help in preparing for the FRQ questions in particular. So that's what I would do. Review the worksheets you completed, practice worksheet 5, and practice the review. And if you feel confident with all 4 worksheets that you turned in and the 5th one that's just extra and the review sheet, then you should be very well prepared for Thursday. Any questions?
Do you think this time's test is harder than last time?
I think it's a little harder, but it's not still to the AP level. It will have a curve because it's not full AP difficulty yet. So it won't be that real steep curve that we sometimes see later in the year, but there will be a curve on this. There wasn't on the quiz last time, but there will be on this.
Oh, okay.
So I think it is definitely a little bit harder.
Do we have time on Thursday to ask some questions before the test starts?
Probably about 10 minutes, not a real long amount of time, but some quick questions. We could go through 3 or 4. Anything else? All right. So the last 20 minutes or so here, I think we get out normally at 1:40, something like that. So these last 20 minutes, you can choose to do what you think you need to do. So if you need to stay online and ask me some questions and check on some things, you can do that. If you want to go ahead and start working through the review sheet or worksheet 5, you're welcome to be dismissed and just start preparing. It's just time for you to do whatever you need to do to prepare. I'll keep the Zoom running in case any of you want to ask questions or need some help with anything. But otherwise, you can be dismissed to work on preparing how you see fit. And I will see you Thursday.
All right. Thank you.
You're
Thank
welcome.
you.
Good day.
Thank you.
Thank you.
You too.